Alright, let's look at some calculations that involve Ka and pH. So first of all, let's define what pH is. pH is the negative log of the hydrogen ion concentration, and you've got it here. pH equals negative log of concentration of H+. Whenever you see the little p out the front, the little p just basically means take the negative log of. So we've got pH is take the negative log of H+. The pKa, take the negative log of the Ka. P grandmother, take the negative log of your grandmother. So that's what the little p means. And you can do the same thing with OH as well. pOH is the negative log of the hydroxide ion concentration, OH minus. Now, as a general rule of thumb, if you've got an exponent, something like 6 times 10 to the negative, and that was your hydrogen ion concentration, that's a fairly typical hydrogen ion concentration, then the pH could be estimated by just looking at the exponent and just ignoring the negative sign, looking at the exponent, and you'll see the pH will be around 4. So if you put this into your calculator and you did negative log, actually you did log of 6 times 10 to the negative 4. That's what you do in your calculator. And then you take the negative of that, it's going to come out to a value that's close to 4. So that's how you would do that. Now, a couple of things we know about this is that if you've got water, water will dissociate, not very much, but it will dissociate into H plus and OH minus. So acidity is going to be based on H plus, and the basicity is based on OH minus. But if you wanted to draw a K expression for that, it would look like this. Products over reactants, so it would be concentration of H plus over concentration of OH minus. And that's over the concentration of water. In a solution like this, though, since the dissociation amount is so small, we can assume that the concentration of water really isn't going to change. So we can combine it with the K up here as a constant value, because it's not going to change. And we call this entire thing here Kw. So Kw equals that. And we actually know what the value of Kw is. Kw is 10 to the negative 14. If we take the pKw, that is take the negative log of that, as I said, just look at the exponent, and that's going to be 14. This tells you why the pH scale is based on 14. It's because that is the maximum number for the Kw. So its Kw is 10 to the negative 14. The pKw is 14. The other consequence of this has to do with the pH plus pOH equaling 14. So if we go back to our equation, (10 to the negative 14) equals that, because that's what the Kw is. Now if I take the negative log of this side and I take the negative log of this side, here's what I'm going to end up with. I'm going to end up with 14 equals negative log of H plus negative log of OH minus, which means that 14 is going to equal the pH plus the pOH. I mean, this is good because what it means is if we've got the pH, we can find the pOH just by subtracting the pOH from 14 and vice versa. So this is a very good equation to be aware of. What we'll be looking at is the Ka and the Kb. And Ka is defined as being the equilibrium constant for an acid. And we don't include water in the Ka expression. And it's just the concentration of the products over the concentration of reactants. So it's H plus A minus gives Ha. And we know we're always talking about the Ka whenever we see acid or H plus in our equation. Kb is called the base equilibrium constant, and the general formula for that is you've got A plus A, OH gives A plus OH minus. Now the reason we're using OH minus is because we have base. So acids involve concentration of H plus, bases involve concentration of OH minus. Now the way this splits up is if you're forming OH minus, then whatever else you're adding with it must be positively charged to balance it out. So this would be A plus times OH minus on the top and AOH on the bottom. And these are good equations to be aware of as well. Let me also add that one can find the concentration of H plus or OH minus if they have the pH as well. And the way we can do that is we know that pH is equal to the negative log of the concentration of H plus. If I want the concentration of H plus, then what I've got to do is take the negative over the other side, so it'd be negative pH equals log of concentration of H plus. So 10 to the negative pH will equal concentration of H plus. Now in your calculator, that means putting a 10 to the power and then a negative in front of the pH value. The other one that will also work is concentration of OH minus is equal to 10 to the negative pOH. So this, in combination with the other ones, will allow you to get those most of the values you need.